and critique, just as we did ask Dr. Gilruth. We invited him for his comment, and it turns out that it was indeed great. And then when such invitations are so extended to you as older folks, as some of us are kind of getting to be constructive and encourage both creative designers and the performing engineers and others and everybody. Be very encouraging, and don't be negative unless you know the person is dead wrong, and you know it. And it's very difficult to know those things. And lastly, I discovered that I needed around me an awful lot of people assuming an awful lot of responsibility, and I came to discover that people can assume tremendous responsibility if one assigns the responsibility to match their potential capability. You have to provide checks and balances to ensure that such responsibilities are assumed and backed up until they really mature. And you shouldn't take the responsibilities away from people that are really assuming them or trying hard to assume them without cause. You should nourish it, and you'll be glad you did. And that's the lessons that I think I learned.
Ken?
That I'd like to pass on.
Do you have any?
Yeah, I got one. Is this on? I can't tell.
Yes.
Yeah. In addition to the terms creative, innovative, and so forth, I want to add the word endurance, and I'll give you a very specific example as an engineer. Several times in the talks, I think there were some questions about Apollo 13. Well, I was responsible for the control systems, and in the lunar module, when we had the failure on the command service module on Apollo 13, and as we went around the moon, we needed a burn out of the lunar module. And we had decided early in the program that was not required for the lunar descent propulsion system to be fired when it was connected to the command service module, okay? And I will pass on my endurance lesson, and that was, I was very interested in having that capability with the lunar descent propulsion system. In a docked configuration. I went before Dr. Kraft, Chris Kraft, who was head of the software control board for all of you software buffs, and he says, boy, the impact was just too much. But he pulled me aside after the meeting. He said, Cox, whatever you do, if you get a chance, slip that capability in there without telling me sometime. You know, I wouldn't be too unhappy. So I went to MIT Instrumentation Lab. I talked with George Cherry, who was headed up the LIM digital autopilot design. And I said, George, we got to get that thing in there. And in effect, we did. Now, it turned out that the backup, which was an analog system, we went to Grumman, and Grumman gave us a great big, horrendous impact. And so we never implemented this docked configuration control system in the backup analog autopilot. But we did in the primary. It was a software change for all of those who've taken this rap that says software costs too much money, et cetera, et cetera, et cetera. It was easy to do, and we did it. And so I got it all done, and I showed back up at an appropriate time where there was a collection of other software modifications for the, I forgot what the program was. It wasn't Colossus, Luminary, I believe it was. But anyway, in the software associated with the lunar guidance computer, and I dumped it into the software control board with very little impact because we'd already done it, okay? And Chris says, fine, let's do it. There was no way I could have realized that we would have ever have had the Apollo 13 incident. The truth of the matter is it was the endurance that says, if I can really get it done, I'm going to try to do it, okay? That's an example.
And if I may follow up on that, I would say that two things. One, knowing what your systems are capable of is very, very important, and not just relying on what their spec values are or what your nominal mission might be. And I know from an engineering standpoint, we have to fight that often just to know what our hardware can provide for us. The other thing that I would add is attention to engineering detail. And, you know, as engineers, and we like to be managers, but if we don't do our engineering job correctly, all the way down to the thermal switch that was in the oxygen tank that shorted out, that caused us a problem with Apollo 13, to the O-ring that was in the Challenger. Very, very minor detail, but very, very important. And in fact, people often ask, what is the most critical item? And you know, we get asked that question often, and I know some people don't like my answer, but I say it's the item that bit you last. The one that was easy enough for you to take care of had you just realized it on the front end. On a Challenger situation, for instance, I'm of the opinion we probably had the technical data in about 1979 to know that we were getting too much gapping in the O-rings, but I don't think anybody in the program picked up on the fact there was too much gapping. We had a similar situation with the Apollo 13 and with the thermal switch in that arena. So attention to detail, we just can't overlook, and it's very, very important.
Ben?
Okay, there's been a number of times people have referred to that this was all done with ordinary people, and I think that's a pretty good summary. Ron Barry said when he came to work, he'd about 4 years out of college and really didn't know much, and as I recall, a lot of us were in that same position. I think that should be encouraging to those of you that are now starting on new programs that we're all pretty ordinary, but with hard work and with communication that Joe mentioned, there was a lot of good communication in Apollo, and there wasn't an awful lot of fighting over whose sandbox belonged to who. We pretty much knew what we had to do, and in spite of our inexperience and the fact that we're pretty ordinary, we were able to accomplish great things. And I think the young people that are here today at the center are actually capable of doing even greater things.
Chuck?
Well, I'd like to echo what's been said about communication. I think Joe hit an important point here. I can remember hours of CCB, Configuration Control Board meetings after the fire, and I learned more about engineering than I ever cared to know. I hope they learned a little bit about medicine that maybe they didn't want to know either. But I think we did a great deal of sharing. We learned that you have to have all of this information, and an engineer can't do something that's going to impact a man without understanding what it's going to do to the man. And vice versa, we can't say the man is limited here without understanding what's happening from an engineering point of view. Lastly, I would say the most important thing that I think I learned from the entire thing from a medical point of view was that you have to have the courage to sometimes go ahead when you don't have all the data. There's always going to be somebody saying you got to have all the data. And the scientists will stand out there and say, here's what it takes for all the data. You're never going to have all the data, and we'd never be there if we waited for all the data. So don't wait for all the data.
Thank you, Chuck. And I'd like to thank all of you who have been faithful and stayed the distance. Tomorrow's session will be flying the Apollo missions. It will be moderated by Joe Allen and will consist of a group of our flight directors, Glenn Lunny, Gene Krantz, Jerry Griffin, Cliff Charlesworth, and others. Thank you very much.